Good morning, ma'am. Myself Devi. I am from ECE. My roll number is 234318042, and today my topic is Cauchy-Riemann equations. First, we can go through the introduction of Cauchy-Riemann equation. First, we consider let W is equal to f of z, where f of z is equals to u of x comma y plus iv of x comma y is said to be Cauchy-Riemann equation, where ux comma uy comma vx comma vy exist at z0, where z0 is equals to x0 comma y0, and also satisfies dou u by dou x is equals to dou v by dou y, or ux is equals to vy, or partial differentiation at u is equals to minus dou v by dou x, or uy minus uy is equals to minus vx. Next we can go through the procedure for Cauchy-Riemann equations. Suppose that f of z is equals to u of x comma y plus iv of x comma y, and that f dash of z exists at a point z0 is equals to x0 plus iy0. Then the first order partial derivatives of u and v must satisfy or exist at x0 and y0. They must satisfy the Cauchy-Riemann equations ux is equals to vy and uy is equals to minus vx. Next we can go through the analytic function or homomorphic function. A function is said to be analytic at a point if it is differentiable everywhere in some neighborhood of that point. A function is analytic in a domain if it is analytic at every point on the domain. If a function is analytic at every point in the complex plane, then is called entire function. Next we can go through the one example. A function is analytic in a domain D if and only if the function has continuous partitions that satisfies the Cauchy-Riemann equations for all points in D. For example, f of z is equals to z square. It is analytic at anywhere, so it is analytic. Next we can go through the Cauchy-Riemann equations for polar coordinates. We know that z is equal to x plus iy, where x is equal to r cos theta, y is equal to r sin theta. Then z is equals to r cos theta plus I sin theta. Next z is equal to r cos theta plus I sin theta. Here we can take the common r, and then we can get z is equals to r of cos theta plus I sin theta. This cos theta plus I sin theta can be represented as e power I theta. Then we can write as f of z is equals to u of r comma theta plus iv of r comma theta. Dou u by dou r is equals to 1 by r dou v by dou theta, comma dou v by dou r is equals to minus 1 by r dou u by dou theta. F dash of z is equals to e power I theta by into dou u by dou r plus I dou v by dou r. Next we can go through one example question. Here the question is, show that the function f of z is equals to xy square into x plus iy by x square plus y power 4, where z is not equals to 0 and 0, z is equals to 0. Show that the function is not analytic at the z is equals to 0, although Cauchy-Riemann equations are satisfied at the origin. Next we can go through the procedure. First we can write the question, what they are given in the question. First, f of z is equals to xy square into x plus iy into iy by x square plus y power 4. F of z is equals to x square y square plus I xy cube by x square plus y power 4. Comparing the above equation with u plus iv, where u of x comma y is equals to x square y square by x square plus y power 4, and v is equals to xy cube by x square plus y square y power 4. Then partial differentiate with x at the function at the origin. Limit x tends to 0, u of x comma 0 minus u of 0 comma 0 by x. It is the formula. Next we can substitute all the values, then we can get 0, and similarly for y also we can get 0, and we can differentiate with v at the origin, then we can get 0. Next we can go through the hence we can say that the function is satisfied at the origin by CR equation. Next we can go through the f dash of z is equals to limit z tends to z0 f of z minus 0 by z minus 0, and substitute f of z in the above equation and z value, where z value is equals to x plus iy. If z gives rise to 0 along the line y is equals to mx, substitute where the y is in the equation, then substitute y is equals to mx in all the above equation. Finally we can get the limit x of x m square plus I m cube by 1 plus x square m power 4 into 1 plus im. F dash of 0 exists. The above equation is not analytic at z is equals to 0, but Cauchy's Riemann equations are satisfied at the origin. Thank you, ma'am.